Our today's topic is the properties. So we will continue the properties of correlation coefficient. So what was the property 1? The property 1 was Rxy, it is lying between -1 to 1. Property 2. So we are talking about correlation. हम correlation analysis की बात कर रहे हैं. Right? And property number 2 is it is independent of change of origin and scale. That is, you have Rxy is equal to RUV. This is U and this is V, where U is equal to X minus A upon H and V is equal to B minus Y minus B upon K. Now I am coming to the, you can write it as a corollary of property number 2, or you can write this as an independent property, property number 3. This one is very useful for the numerical computation. You may note down. आप एक नोट लिख सकते हैं इसके नीचे. This is very useful for this theorem or this property is of fundamental importance in the numerical computation of the correlation coefficient. Numerical computation of correlation coefficient, right? Now I'm coming to the property number 3. What the property number 3 states, if X and Y are random variables, if capital X and capital Y are random variables, and A, B, C, D are any numbers provided that दो के ऊपर रिस्ट्रिक्शन है, A is not equal to 0 and C is not equal to 0. Then what we want to prove that the correlation coefficient between R AX plus B, the random variable is now AX plus B and CY plus D, this is equal to A into C upon mod of AC into RXY. So when we will add and multiply, in the previous theorem, in the previous property number 2, what we have done, we have taken the deviations. Deviation means minus, x minus a, and then scale में हमने division किया था. यहाँ we are adding and multiplying. Then it will have this kind of property. It can be solved. It depends upon what is the value of AC. Ultimately, either it will give RXY or it will give minus RXY, right? So let's come to its proof. Now I'm coming to the proof of the theorem. Now, in order to find out the correlation coefficient, what do you need? You need covariance, variance of x and variance of y. So first of all, we will find out all these things. So variance of ax plus b. You know what is the variance of constant का variation हमेशा 0 होता है. So these are the simple properties. This is variance of x. You know, this is a square into sigma x square. Variance of cy plus d. This is again c square. D is a constant quantity. So variation of a constant quantity is always 0. So therefore here is variance of y. So what you will get here, c square into sigma y square, right? So let it be number 1, number 2, and next we will find the covariance. So what is the formula to find the covariance? So covariance between ax plus b and cy plus d. So this is equal to, according to the formula, this comes out to be AC into covariance between x and y. So it is written as sigma xy. So now we will put the formula of correlation coefficient. This comes out to be covariance between ax plus b cy plus d upon variance of ax plus b into variance of cy plus d, right? And its whole raised to power 1 by 2. 1 by 2 नीचे है, ऊपर नहीं है. Here is 1 by 2. So put all the values, let it be number 3. Substitute all the values 1, 2 and 3 in star. Put 1, 2 and 3 in star to get R is equal to, so this is AC into sigma xy upon, this is, what is the value of this expression? This is a square into sigma x square. This is c square into sigma y square and its under root, right? और एक division का sign है और एक under root का. So this is AC into sigma xy upon. So सिग्मा वाइज के आपके पास बन जाएगा स्टैंडर्ड डेविएशन, ये बन गया सिग्मा एक्स, इधर बन गया सिग्मा वाई. लेकिन जब आप अंडर रूट ऑफ ए स्क्वायर आएगा दैट विल बी मॉड ऑफ ए, और जहां पे अंडर रूट सी स्क्वायर आएगा वहां भी क्या आएगा, मॉड ऑफ सी. सो दिस विल बी मॉड ऑफ ए हियर एंड हियर विल बी मॉड ऑफ सी. सो इट इंप्लाइज what do you have, AC into sigma xy upon mod of AC upon sigma x upon sigma y, and this is the formula of Rxy. So AC upon mod of AC, this is equal to, this is nothing but Rxy. So therefore I am combining, so it implies R of, yani correlation coefficient between AXB and C plus YD. This is equal to AC upon mod of AC. So this we want to prove. Now, if we have, if AC is equal to, if A into C is greater than 0, suppose करिए ये quantity क्या है, greater than 0. ठीक है, दैट इज AC ग्रेटर देन कब होगा 0, जब A भी ग्रेटर देन हो 0 और C भी ग्रेटर देन 0 हो. ठीक है जी, यहाँ A भी लेस देन 0 हो एंड C भी लेस देन 0 हो तो आपका AC क्या हो जाएगा. ठीक है, इन अदर वर्ड्स वी कैन से दैट व्हेन A एंड C बोथ हैव सेम साइंस, इफ A एंड C आर ऑफ सेम साइन, are of same signs. So it implies, then it implies mod of AC किसके बराबर हो गया, पॉजिटिव वैल्यू दे रहा है, so that will be equal to AC. It implies, substitute the value here, so therefore R AX plus B CY plus T is equal to AC upon AC, that is RXY. So this comes out to be, that comes out to be RXY. Right? And if it is negative, I'm again doing here, if it is negative, इसे सेकेंड केस है, इसमें ये केस नंबर 1 ले लिया आपने पीछे, अब ये केस नंबर 2 कर रही हूँ इसी में ही. इफ AC is less than 0, then या A greater than 0 होगा, अगर A greater than 0 तो C less than 0 होगा. ठीक है जी, और अगर A less than 0 है तो C क्या होगा, greater than 0. यानी A and C are of opposite sign, right? And when they are of opposite sign, it implies mod of AC आपको आपके पास क्या वैल्यू देगा, ये minus AC वैल्यू देगा. So when you will put the value here, so you will get minus. It implies you have the value is equal to minus RXY, right? So in this case, so this is the conclusion regarding this, ki whatever value of AC will have, then what is the value of R correlation coefficient between AX plus B, CY plus D? Yeah, what is the relation between the variables XY and AX plus B and CY plus D? Next, इसमें आगे रिमार्क है, if I will put B and D is equal to 0, right? आप इसको रिमार्क, ये जो आपने नोटेशंस लिखी है, आप इसको रिमार्क नंबर 1 दे देंगे, दिस वन जिसमें केस नंबर 1 और केस नंबर 2 है. Then remark number 2. Remark number 2. If we take, इसी में ही इसी की बात कर रहे हैं, if we take b is equal to 0 is equal to d in r ax plus b cy plus d, then we have, ये क्या बन जाएगा, दिस विल बी आर ए एक्स एंड सी वाई। देखो कोई फर्क नहीं पड़ेगा आंसर में, क्योंकि आपके फाइनल आंसर में बी और डी ऑलरेडी ही नहीं थे। देन इट विल रिमेन सेम, ए सी अपॉन मॉड ऑफ ए सी आर एक्स वाई। So this is the remark number 2, and this completes the property number 3. Now we will move to the property number 4. Property number 4, या theorem number 4. Two independent variables are uncorrelated, but the converse may not be true. May or may not be true, but the converse may or may not. Two independent variables. If x and y are independent variables, we know that the covariance between x y is equal to 0, right? So we will start the proof. If x and y are independent variables, it implies, we already know that covariance between x, y is equal to 0. When the covariation between the two variables is 0, then Rxy is totally dependent upon covariance between x, y. This is then sigma of x here, sigma of y. This comes out to be 0 upon sigma x, sigma y, that is equal to 0. It implies two independent variables are uncorrelated. We will repeat the line, therefore same line here. Two independent variables are uncorrelated. ठीक है जी. Now we will come to its converse part. Converse is may or may not true. May or may not. जब vice versa पूरा होता है तो it means, इसका मतलब टू इंडिपेंडेंट वेरिएबल्स अनकोरिलेटेड है, और जो अनकोरिलेटेड वेरिएबल्स है वो हमेशा इंडिपेंडेंट होंगे, लेकिन ऐसा नहीं है. कन्वर्स में वर्ड होता है मे और मे नॉट, हो भी सकता है नहीं भी हो सकता, तो हम दोनों तरह के एग्जांपल इसमें करेंगे. सो कन्वर्स ऑफ दिस प्रॉपर्टी, कन्वर्स इज नॉट ट्रू. Converse of this theorem or property is not true, right? So it means we have to take one example to prove this converse. That is, first of all, we will write two uncorrelated variables. Two uncorrelated variables may not be independent. May not be independent. So in order to prove this, we will take one example. For example, so for this, I am coming to the next page because we have to draw a table for the same. So we will make a table here, right? So draw one line here. You have to make 3 columns, then one more. Then we have to calculate. Here is x1. Then I will put the values 1 to column banaiye 1. Then again to put all the values 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. And here this is left for the total. So first of all, we will write down the values of the random variable. You will put x here, you will put y here, you will put x and y here, right? Here you will write -3. The values of x are -3, -2, -1, 1, 1, 2, and 3. One more we can draw, right? Then 9, the values of the random variable are 9, 4, 1, 1. Then again, some are repeating. Here is 2. Here is 2 and here is 3. We will not use this. Right? So 9, 4, 1, 1 and here is 4 and here is 9. Right? And x into y. फटाफट से calculate करेंगे 27 -8 -1 1 4 2s are 8 9 3s are 27. Now we will do the total here. Total means here total word will be there. Like this. Yes, total is here is summation of x. But you will calculate jitni positive values hai utni hi negative hai. The answer is 0. Summation of y, when you will calculate, it will comes out to be 28. Then summation of xy same here. Jitni negative hai utni hi positive values. Now we will calculate. Actually, what we want to calculate. Ultimately, हमने कहाँ पहुँचना है? पहले target देखिए rxy. That is covariance between xy upon sigma x and sigma y. For this, what kind of things we are needed? क्या क्या चाहिए? x bar is क्योंकि deviations आप लेते हैं इसमें से summation of x. आपका ये कितना आ गया? That is equal to 0. ठीक है जी? Next, now covariance between x y. There is no need to calculate y bar क्योंकि वो x bar के साथ जब multiply होएगा, the answer will be 0. So here you will write the value summation xy minus x bar y bar. So 1 by n summation xy, this is 28. 28, whatever value you have, summation xy is 0, right? And x bar is also equal to 0. So the answer is equal to 0, right? So therefore, you will put the values here. Therefore, rxy is equal to 0. So it means rxy is equal to means x and y are. It means x and y are uncorrelated variables. Are uncorrelated variables. But it doesn't mean x and y are independent. But it doesn't mean y and x are independent because they are connected by the relation. अब देखिए x की values -2, -1, -1, 1, 2, 3 है. Y क्या है? उसका square हो रहा है. It means they are connected by the relation y is equal to x square. So the variables are uncorrelated means there is no linear relationship between these two variables. So here is a relationship is of curvilinear. Right? And it doesn't mean they are independent. They are not independent. They are dependent. They are dependent of each other. So the converse of the theorem states that two uncorrelated variables may not be independent. Rxy is equal to 0 means the variables are uncorrelated. It doesn't mean they are independent because there is a relation of curvilinear relation between two variables. अगर linear relation आता है then we will say यहाँ पे क्या relation आ रहा है, curvilinear relation, right? So we will do one more example of this kind. Yes. So next example for the same. For example, example number 2. Suppose x is a random variable which follows normal distribution with mean 0 and variance is equal to 1. And y is equal to x square, right? Now, we know that when x follows n0, 1, then the odd order movements are 0. It implies expectation of x is 0, which is equal to expected of x cube, right? Therefore, covariance between x and y, this is equal to covariance between x and y. This is equal to expected of xy minus expected of x into expected of y. So you will put the value of y here, that is expected of x cube बन गया. ये expected of x की value पहले ही 0 है, into expected of y, और यहाँ से expected of x की value भी क्या आ जाएगी, 0. So this comes out to be 0 minus 0 is equal to 0. So therefore covariance between xy is equal to 0. Now what we want to find, Rxy is equal to covariance between x and y divided by sigma x sigma y. So that comes out is equal, it implies, इसके बाद ये step आएगा, this implies this is equal to 0. अब यहाँ से देखिए, the variables are not independent because y is dependent upon x with the relation y is equal to x square, but their correlation between them is 0 because there is no linear relationship between these two variables. Now we will do one example where this property holds. Yes. Now, this was example number 2 where the converse may not hold. Now we will do the example where converse holds. Examples where the converse of above theorem holds, right? That is two uncorrelated variables are independent. That is two uncorrelated variables are independent. This we want to do, right? So let us take हमने x एक random variable लिया है. Let us take x is a random variable and y is the random variables. x और y दोनों ही की क्या values हैं, 0 and 1 with positive probabilities. Let the two random variables x and y takes the values 0 and 1 with positive probabilities. Positive probabilities. It means x ने दो values ली, x has a two values 0 and 1 and the probability of x will be, suppose I have taken p1 and p2. ठीक है जी? Similarly, same here, y is 0 and 1 and actually we didn't give exactly what is p1 and p2. We just have given, we will assume this is p1. यहाँ p1 p2 नहीं लेंगे हम. यहाँ पे आप assume करोगे होने की probability p1 होगी और ना होने की क्या होगी, q1. So this is p1 and this is q1. So same here, this is q1 and this is P1, ठीक है, जो श्योर प्रोबेबिलिटी इज P1 और ना होने की प्रोबेबिलिटी Q1. देन सो मैंने टेबल बना दिया. अब प्रूफ में इसको अपने लैंग्वेज में कैसे एक्सप्रेस करना है. लेट x टेक द वैल्यूज, let x takes the values 1 and 0 with probabilities P1 and Q1, ठीक है जी, रिस्पेक्टिवली. एंड y सिमिलर जैसे टेबल बनाया था पीछे, y take the values 1 and 0 with probabilities P2 and Q2, ठीक है जी. Then Rxy is equal to 0 implies covariance between xy is equal to 0. Because we have already given the statement that statement में क्या कहा है कि x और y दो random variables हैं which are taking the value 0 and 1 with positive probabilities, then Rxy is equal to 0. This is given in the statement, and Rxy is equal to 0 implies x and y is independent. ये कंडीशन दी है, प्रूव करना है x और y क्या है, इंडिपेंडेंट है. So Rxy 0 implies covariance between xy is equal to 0. Substitute the value of covariance between x and y. So this is expected of xy minus expected of x into expected of y is equal to 0, right? So it implies, so you will put the value here, that is probability of what is expected of xy, that is probability of x is equal to 1 intersection y is equal to, होने की probability तो यही होगी ना, माइनस, और दूसरी क्या होगी, probability of x is equal to 1 into probability of y is equal to 1. So it implies that this is equal to 0. So it implies probability of x is equal to 1 intersection y is equal to 1. This is equal to probability of x is equal to 1 into probability of x is equal to 1 into probability of y is equal to 1. So यही आप प्रूव करना चाहते थे, that is expected of xy is equal to expected of x into expected of y implies x and y are independent. So this is an example where uncorrelated variables are independent. So that's all for today. I hope the point is clear to all of you.